All right. Let's talk about this 5.2 machine depreciation. So we got after purchase, the value of a machine depreciates exponentially. Remember, when we do talk about exponential depreciation, that's, and bear with me because I'm using my mouse, y equals a 1 minus r and then a t. Okay, because we have to subtract the rate to make it go down. So that's kind of our exponential decay or depreciation function. So we got a table. It shows the value as a fraction or a function of years since purchase. If a spreadsheet tool is available, consider using it to help you as you go through. So basically what that means is if you've got Microsoft Excel or if you've got Google Sheets or not Sheets, maybe it is Sheets. Yeah, Google Sheets. Or even if you can use Desmo's little piece there, then maybe consider using that as a helpful tool. Do you have to do that? No, you don't have to do that. So that's just kind of a helpful hint for you. So this says years since purchase and then value in dollars. So we know as we go up a half year or a whole year, we can see the value goes down from 1 whole year, skipping the half. We can also see from 1 to 2 and 2 to 3 what that kind of jump is. So we know that a jump between 0 to 1 is, we're losing some value. So we can figure out what that value is. Now, let's say 1600. That's our starting value, right? That's A. Let's call that A. Then we're going to say 1600, 16,000, not 100, 16,000 times, and we're just going to make it a factor. Why don't we just make this a factor? We'll call it B. 1 minus r we can deal with in a minute. And what we know is that we're going to go a half year, or if we go a whole year, right? If we go 1 whole year, we know that the new value is going to be 13,600, right? So what I could do here, a couple different ways, and I'm going to pull over one of them that might be super helpful, is to use Desmos. Like we've said before, Desmos is a fantastic tool to use. I want to use my scientific calculator for this one. I don't want to graph it necessarily. All right. I don't even know if this is following me to this tab or not. I'm not that familiar with Screencastify. But if it is, we know that, here, I'll share this tab with you for the people on the Google Meet. All right, we've got 16,000 times b to the power of 1, and that's going to take us to the 13,600. So what you can do, actually, I'm going to go back over here. We'll do the math in Desmos in a second. You're going to divide both sides by 16,000. Those are zeros. It's fun using a mouse to write. This is why I wish I had a pen to write with. I'm not those guys from Khan Academy. All right, so now I'm going back here to the Desmos calculator, and I believe it was 13,600, and then we just divide it by 16,000, and we get 0.85. So what that means is that B, or our factor B, is 0.85, right? 0.85 is our factor. So what that means is that for every year that we go down, our car's value is 85% what it used to be worth for every year. So how can I get to every half year, right? That's kind of the consensus. How am I going to get to the half year now? Because the first question says that the value of the machine in dollars is a function of time. Find an equation defining F prepared for your reason. So we already really did that. Y equals 16,000 And the reason it's 16,000 is because that's where our value of our car started, or machine, whatever we're talking about here. And then we know that per year, because this is wants the number of years since the machine was purchased, is going to be 0.85. We just found that. And then we'll just call T at the top, and T is time in years, right? T is time in years. So I guess I'll leave that there for a second. That's a really cool feature that this thing just keeps my work there. Part 2 says find the value of the machine when T is 0.5 and 0.15 and record these values. So we know T is time in years, like 1 year has gone by, right? So what if I was to now go for 0.5? Well, I would put 0.5 in for T. And so we could say then 16,000, and then we'll do that 0.85. Either I'm going to get better at this or I'm going to buy a pen. And now our power is 0.5 instead of 1, right? Because we know that T is time in years. We're just going to put a 0.5 up there. So I'm going to go to share this tab, and I'm going to type that function in because we have a great calculator that will literally do everything for you except for the conceptual part. And I'm going to raise this to the power. 0.5 is the same as 1/2, which is a fraction. And now that is our new value. Let's round that to the nearest tenth because we're talking money. So we'll say 14,751. Now that should make sense to you because that's more than this 13, right? 14,000. Let me double check my work here because there's a bunch of numbers. 751. Does our thing tell us to round it anyway? No. And then 0.27 underneath that work there. So 14,751.27, that's our value in dollars. And again, that should make sense because it's less than 1,600, but it's more than 13,600. 16,000. I'm going to get that right. So then if we wanted to do the same thing for the 0.5, we would just say 16,000. See, I told you I'd get it right. Times 0.85. But our power this time is going to be that 1.5. Now, when I go to Desmos, I can do a really cool thing here with Desmos. I can copy and paste. Control C, Control V, and then I'll just change that power to 3/2. That's the same as 1.5. Or if you're like, I don't know how we did that, you can literally put 1.5 in and you'll get this 12,538.58 because we'll round. So that's our new value here for 1.5. So 12,000. What did I have? Well, I got to go back for the other one. 12,538. I think it was 0.58, but I'm going to double check. 0.58, I was right. Hope I'm not giving people who are watching this video too much whiplash going back and forth. If I am, sorry. So now that's the completed number 1 and number 2 for that table, okay? If I look here at number 3, it says observe the values in the table. By what factor did the values of the machine change? So when it's saying that, you want to find this value of B we found before, that 0.85, but now they're going to change it up because that was per year. This says for every year, say from year 1 to year 2, or from 0.5 to 0.15. Now that should remain the same, 0.85. We already found that factor, right? 0.85 or 85%. That's every year. And what you can do is you can take their values that 12,538.58 and divide it by 14,751.27. And you should get that 0.85. And we can do that, right? We can check that. Let me share this with you. Just to prove to you that it's the same thing as what we found earlier in this problem. we will take that and divide it. Oops, I put the wrong one there. I'm just going to copy that, put it at the bottom. I got to put the smaller number up top because that's after time has passed. So the 12,538.58. And look, 0.85, like I said. So let's go back and let's say, all right, well, what if it was every half year, say from 0 to 0.5 or from 1.5 to 2? So in this case, what we're going to do is we're going to take this 11,560 and divide it by the half year change. So we'll say 11,560 and divide that by 12,538.58. And that will give me the factor. Man, that makes my fingers really hurt writing it out like that. So what was it? 11,560. Ooh, okay. Divided by 12,538.58. So what's the percent value change every half year? Let's just round it to, let's say 92.92. So this one is 0.92. Is that even showing up? I don't know. I'll clear all the work and I'll write it again. Where are we at? Why is this doing? There we go. Nope. Something's going on. It's all right. Maybe I've exceeded this. Let's try again. Extending my computer's processing power here. It's like you shouldn't be able to write on things. Anyway, it's that 0.92 that we found from before. Number 4 says, suppose we know that f of q, or suppose we know f of q, the value of machine, q years since purchase. Explain what we could use f of q to find f of q plus 0.5, the value of the machine half a year at that point. So how am I going to take this whole idea of f of q, and q is years since purchase, to explain how we could use that and find this kind of f of q plus 0.5, the value of half a year after the point. So essentially this, we're plugging this into the function now where half of year goes by. Gonna let me write yet? No. I don't even know what's going on right now. Anyway, suppose we know that f of q, the value of machine, q years since purchase. So the function we know is called f of q. This is where people get confused. F of q, what is that? Well, it's just a function. That function represents the value of the machine, q years since purchase. Explain how we can use that to find now the plus 0.5, and that's the 0.5 years after purchase. All that work we did before up here where we were writing all this stuff in, that's how we can find it. Okay, this is our function. All we have to do is now add the 0.5 in there to find the new rate. So that's what we could do in that case. Sorry, I'm just having some issues here writing for whatever reason. So I don't know what's going on exactly, but it's fine. Are you ready for more? This is not something that you have to do. If you really wanted to do more, you could. So if you guys are confused about it, let me know and I'll go through that one as well. I believe the answer key's back in 2.1 day 1. Fever machine. I think we did this one in class. And most of you have done that one already. So we're going to stop here because I think you two did that one already. All right, let me stop my recording.